Okay, in this video, I want to discuss the associative property, and it's something that sort of shows up in arithmetic, and it doesn't really seem all that useful at first when we learn about it, but I promise you that as you move on to harder, sort of more challenging, involved questions in calculus or even algebra, this associative property comes into play. So let's see what it is first by doing a quick demonstration. So what if I had the numbers like 1 plus 2 plus 3, and I don't know about you, and as far as anyone that I've ever met, I don't know if anyone adds three numbers in their head all at the same time. Typically we do 2 by 2. So if you were to add this up, you're probably going to add like maybe 1 and 2 first and then add the 3. And so we could think about it as grouping or associating the 1 and the 2 first and saying 1 plus 2 is 3 plus 3, and we say that's 6. But what if we did it differently? So what if we had the same problem, but instead of grouping the 1 and the 2, we group the 2 and the 3? Or another way we could say it is we associate the 2 and the 3 together first. So we say, let's add those together. 2 plus 3 is 5, and then add the 1. Well, still 6. What if we use the commutative property to sort of swap the 2 and the 3? Because we can do that, right? Commutative property says the order doesn't make a difference. So if I rewrote the problem as 1 plus 3 plus 2, and I decide I'm going to group the 1 and the 3 first, add those, and then add the 2, well, I get 1 plus 3 is 4 plus 2, still 6. And so the associative property, which has this root word associate, says it does not matter how you want to group numbers or associate numbers. When you're doing a bunch of addition, right, then it doesn't matter. It doesn't have any effect on the answer. We see that no matter how we chose to group these, we always got the answer 6. And so this is called the the associative property of addition. And it basically goes something like this. Like the formal way of saying it is like if you have A plus B plus C, and these are just like they're stand-ins for numbers because the numbers themselves don't matter. It's just saying, look, if you're adding three numbers, and this property, by the way, doesn't work for only three numbers. It works for any amount of numbers, but we don't want to sit here and just write numbers forever. So we're just going to do the minimum we have to do to make a point. So if we have A plus B plus C here, and that obviously equals itself, A plus B plus C, we're saying, look, if you group A and B together first, that's the same thing as if you were to group the C and the B together like that. You get no difference in outcome. And vice versa. We could have grouped, the A and the C and then the B and the A or whatever. On the other side, it doesn't matter. You're always going to get the same answer. Okay. Let's see. Is there an associative property of subtraction? Okay. So if we talk about, let's just write some numbers. So 1 plus 2, let's just do all subtraction. 1 minus 2 minus 3. Okay, 1 minus 2, if we did that first, and then minus 3, so you get 1 minus 2 is negative 1, minus 3 is negative 4. But what if we have 1 minus 2 minus 3? If you group it like that, right, where you're grouping, you're not including the symbol here, that says 2 minus 3 is negative 1. Okay, 1 minus negative 1. So let me rewrite that. 1 minus negative 1. Well, that becomes 1 plus 1. That's 2. So we see that you can't group it that way, at least not the way we did it. Now, of course, like with the commutative property, there was like a workaround with that, with subtraction. And I'll show you it works the same. So if we had 1 minus 2 minus 3, and by the way, the proper way of doing this, if you're just going to have it all minus, is to do kind of left to right. We're saying we're subtracting 2 from 1, and then we're subtracting 3 from whatever that is, right? But what if we had done it? What if we want to group the 2 and the 3 together? If we do that, we need to say, look, this is the same thing as saying 1 plus -2 minus 3, right? Any minus, any subtraction, I should say, can be rewritten as plus the negative of the number. And then if we decide to group those, right, like that, well, and by the way, what is this again? We said it was -4, right? 1 minus 2 minus 3 is -4. Well, here we get 1 plus, and then we have -2 minus 3 is -5. And so we get that 1 plus -5 is the same thing as saying 1 minus 5, and it's equal to -4. Okay, we got the same answer. So directly, you can't use the associative property with subtraction, but if you account for the sign in front of the number you're choosing to group, then it does work. So you just got to recognize that when you have a minus sign there, you need to be doing a plus a negative number, or you need to carry that negative in with the 2, for example, because it's -2. But then the sign can't just simply disappear, right? If we did this, that's something different. That's saying 1 times, we're not saying anything about plus or minus with these parentheses. So that's like saying like 1 multiplied by -2 minus 3. So you have to convert that into what it really is. It's a plus -2. Okay, so then what about multiplication? Do we have an associative property for that? Okay, well, if we have, let's do some numbers real quick. 1 times 2 times 3. And then here we're going to do it again. 1 times 2 times 3. But let's group the 1 and the 2 together here. And let's group the 2 and the 3 together here. Okay, 1 times 2 is 2. 2 times 3 is 6. Okay, 1 times, well, we have to do the 2 times 3 first. 2 times 3 is 6. 1 times 6 is 6. Well, that seems to work, doesn't it? Let's move the 3 around, because we can use the commutative property on multiplication, right? Move the 3. So I'm just going to have a 1 times 3 times 2, and I'm going to say, let me group the 1 and the 3 together, and then multiply by 2. So 1 times 3 is 3, right? Times 2, well, that's 6. And if you don't believe me, because I have this 1 here, you might be like, well, of course it's like that because there's 1. Let's try something else. Let's do 2, 3, and 4. So what if I had 2 times 3 times 4? And I group the 2 and the 3 first, and then multiply by 4. That's 2 times 3 is 6 times 4 is 24. Okay, but now I'm going to group it differently. So 2 times 3 times 4, where I group or associate the 3 and the 4 first. I got 3 times 4 is 12, and then I'm multiplying that by 2. Well, 12 times 2 is 24. And so we see that the associative property does hold for multiplication just as it does for addition. So essentially the rule, the associative property of multiplication is written in general form, much the same way we write it for the associative property of addition, where we say, look, if you have a number A times some other number B times some other number C, and you group A and B first and then multiply by C, it's the same thing. It's equal to if you had A times and you decided to group the B and the C together like that. It's the same. It doesn't change the answer. And of course, as I said before, it doesn't matter if you have 3 of them, if you have 4 of them, if you have like thousands of terms there being multiplied. It doesn't matter how you choose to group these things. In terms of, when I say it doesn't matter, is it doesn't have an effect on the answer. It doesn't change the answer. It does matter because sometimes by doing this a certain way, you will actually make a hard problem simpler. And again, you're going to see more examples of why that is when we're actually getting into algebra and later on in calculus especially. So, okay. So so far we have there's an associative property of addition. There's an associative property of multiplication. About division. I don't know if you remember from the commutative property video, but this is sort of following the same pattern. So we probably wouldn't expect it to work for division, right? So let's think about this. So, and of course, if we write division like kind of like the elementary way, it really makes the point, right? So if you have 4 divided by 2, right, and then you divide that by 1, well, let's think about this. So 4 divided by 2, well, that's 2, right? And 2 divided by 1 is 2. Okay, what if we had grouped it the other way? So what if we said 4 divided by 2, but that's divided by 1 first? Okay, 4 divided by, well, 2 divided by 1 is 2, so 4 divided by 2, it's still 2. It might just work then, right? Well, not so fast. We also could maybe potentially have just gotten lucky. Let's try some other grouping, shall we? So what if we had 6 divided by 3, and that's divided by 2. Okay, so I want to do 6 divided by 3 first. So that's 2 divided by 2 is 1. But what if I say 6 divided by 3 divided by 2? 3 divided by 2, that's 1.5. So now we're talking about 6 being divided by 1.5. Well, I can tell you right now that that's not equal to 1. So what, I don't know what that would be equal to, by the way. I'm interested to see. Well, I could quickly do it the right way. So if we had 6 over, this is how it should be written, 6 over 3 halves. Well, that's equal to 6 times 2/3, and we see that, oh, yeah, I should have known that. It's equal to 4. I'm silly, I should have known that. So we see that 6 divided by 1.5 is 4. So guess what? Doesn't work with division. Now, if you write it properly, you know, and when I say properly, I shouldn't say properly as if this sort of notation is improper, but it isn't. It's very vague. So I wouldn't write it that way. I would write, you know, if I had 6 divided by 3 divided by 2, the way it should be written is 6 divided by 3 divided by 2. And here, it should come in like pretty clear how you do something like this. You have to, well, I guess maybe it's not all that clear. You have to determine what is your numerator and what's your denominator. Normally the fraction bar wouldn't be written so ambiguous the way I have it here, right? If it was written this way, it's where the larger one is on top, then we're saying this is 6 divided by 3 halves. But if it was written the other way, you're saying we have 6 over 3 divided by 2. Well, 6 over 3 would be like doing it this way, right? Or if we had 6 divided by 3 halves, that would have been doing it that way. And so we see, you know, even if we write it out using the fraction bar, it still could be ambiguous unless it's made perfectly clear which one is, you know, a fraction and which one is like sort of the large. I guess there's a fraction within a fraction. It's like what's what here? Are we talking about this being one numerator and that being our denominator? Or are we talking about the 6 being a numerator and the entire 3 halves being a denominator? And so we see that this whole thing with associative property and division just doesn't work out well. Okay, so to recap then, the associative property, like the commutative property, holds for addition and for multiplication. So you can group these guys however you want. It will not affect the answer. It does not work for subtraction, and it does not work for division. Okay, so I guess I'll see you in the next video.